So now we talk about current, right? And before that, we have talked about charges, right? Charges. Do you know what is the basic unit of matter? You are very smart. I am asking basic unit of matter. Basic unit of matter. Atoms, man, not molecules. Molecules are made up of atoms. So this is atom, right? And an atom is made up of what? Atom is having nucleus, right? Inside nucleus there are protons positively charged and neutrons are electrically neutral. Outside nucleus there is electrons revolving in different energy shells, right? In first shell 2 electrons, second shell there are 8 electrons, right? So here is 1. So if it loses 1 electron, then what happens? There is 3 unit positive charge, 3 unit negative charge, 3 electrons are there, but 1 electron comes out. It lost 1 electron, right? So which charge is greater now? 3 unit positive charge, 2 unit negative charge, because 3 electrons are left. So which charge is greater? Positive charge, yeah. Positive charge. So this atom get positively charged. Atom get atom get positive charge, right? It gets positive charge, and in the next way, if you have, you know, if I talk about another atom, so what happens? This is proton. There are 17 protons, right? And 17, neutrons. I do not know because neutrons number is something odd. So 38.5 neutrons, and there are electrons in different energy shells, right? So different energy shells, there are 2. Then we have, you know, 8. And there is, in next orbit we have 7 electrons. 1, 2, 3, 4, 5, 6, 7, right? If it takes 1 electron, when it takes 1 electron, then what happens? It takes 1 electron. So how much negative charge it is carrying? Negative charge of 18 unit, right? But positive charge remains of 17 units, right? So it means it gets 1 unit negative charge. 1 unit negative charge. Is it negatively charged? Unit negative charge, right? Negative charge. So what is that? What I mean to say, charges are developed. Charges are developed by losing or gaining electrons, or gaining electrons. Getting? Losing or gaining. losing or gaining electrons. Okay, so now we have if you take you know if you take a glass rod, right? If you take a glass rod, this is a glass rod, and this is silk silk cloth, right? Silk cloth. So what happens when you rubbing glass glass lose electrons and get positive charge. So this rod get positively charged, right? And if you take a rod of ebonite, this is the ebonite, rod of ebonite, when you rub on the wool, this is wool, right? Then so here what has done, this glass loses electron, this glass loses electron, right? Loses electron. And here what happens, this ebonite rod takes electron, takes electron. When it takes electron, so what happens, it gets negatively charged, right? So this ebonite rod get negative charge by taking electrons, from wool, right? Now what happens, these two rods are like this, this is a glass rod, this is positively charged, this is positive charge, positive charge, positive charge, positive charge, right? And there is also another glass rod which is positively charged, right? This glass rod is also positively charged, and we have an ebonite rod which is negatively charged, right? Negatively charged, and this is also a negatively charged ebonite rod, right? So what will happen between these two? There will be force of repulsion, right? They will repel each other. So we can say this will also and this will also repel, right? This will also repel this and this and this and this, right? So between same charges there is force of attraction. Sorry, between same charges, are you with me? Between same charges, there is force of repulsion, force of repulsion, ठीक है? And between opposite charges, अभी क्या होगा, this ये इनके बीच they will मतलब this plus charge will attract this and negative charge will attract this, right? This negative positive charge will attract this, negative charge will attract this. So in opposite, between opposite charges, between opposite charges there is force of attraction, force of attraction, is it? Force of attraction, fine. अभी क्या है कि electron is having, one electron is having a charge of 1.6 into 10 की power minus 19 coulomb, right? Or we can say 1.6 into 10 की power minus 19 coulomb is equal to 1 electron, right? So 1 coulomb is equal to how much? 1 coulomb is equal to 1 upon 1.6 into 10 की power minus 19 electrons, right? When you solve this, you will get 6.25 into 10 की power minus 18 electrons, right? Okay, so what is electric current? Electric current is rate of flow of charges, rate of flow of charges, right? Or charge flowing in unit time, right? Charge flowing in unit time, that is known as electric current. So I is equal to Q upon T, right? So we can say that I is equal to, no, not this implies equal to, Q is equal to NE, where N is number of electrons and E is charge on one electron. So it means, so in broad way we take, it means electrons, SI unit of current is ampere. So 1 ampere is equal to 1 coulomb per second, right? Sorry, 1 coulomb per second, right? Did you understand what I said? 1 ampere is 1 coulomb per second, and in 1 coulomb how much charge is flowing? Sorry, how many, no. In 1 coulomb how many electrons are flowing? Yeah, that is. It means if there is 1 ampere current, it means 6.25 into 10 की power 18 electrons flowing per second, right? I hope you understand this whole concept of charges and electric current. You understand? Unit of electric current is ampere, huh? Should I write? SI unit, SI unit of electric current is equal to ampere, right? This is we have. Now should I rub this? If you are writing, you just take, if you are writing, just make a note. If anything is left, I'm just coming, right? You have written also, you're writing or not? Small point. Okay, great. What is level of your importance? It is very considering, huh? Anyway, you concentrate on you know, understanding the things is more required in spite of writing. Otherwise, if you're busy in writing, so you will not able to understand the things. This much is current we have, right? I'm going to rub this. Okay. Now, right. So these are atoms. Oh, sorry. These are atoms, right? So what happens? This atom loses electron, right? Loses electron. So what happens? Loses electron. So it gets positive charge, right? And since it is taking electron, so it gets negative charge, right? Now this atom loses electron, it gets positive charge, right? It gets negatively charged, right? Again, again this is losing electron, it gets positive charge, and it is getting negative, right? Now it gets negative charge when it loses an electron and gets positive charge, right? And when it is losing a positive charge, it is getting negative charge, right? So this is getting negative charge, so this is on losing electron by 8, it gets negatively charged, it is positively charged, it gets negative charge when it loses an electron and gets positive charge. When it gets positive charge, it gets negative charge, right? When it loses electron. So what do you see here? Positive charge is flowing in this direction. Positive charge, positive charge flowing, right? And this is direction of flow of electrons, right? So this is uh, flow of direction of flow of electrons, direction of flow of electrons or negative charge, right? And this is positive charge flowing. So charge of flow positive charge flowing opposite to opposite to opposite to flow of electrons, right? This flow matlab positive charge flowing opposite to the flow of electron, and flow this belongs to direction of conventional electric current. Yeah, yeah. So current is right. Current is a scalar quantity basically, right? So this is positive charge flowing opposite to the flow of electrons. So this is direction of flow of direction of direction of flow flow of direction of flow of electric current. Electric current, right? Electric current, right? Electric current flows from opposite to the flow of electron. So electrons are moving in this direction, right? It is in this direction. So electrons are flowing. So positive charges are flowing in this direction, right? So direction of flow of electron is opposite to flow of is opposite is opposite to flow of electrons right? Please, I'll talk with you later, please. Let me finish. Right. Right. So this you understand well. Direction of flow of electron is opposite to the flow. Sorry, direction of flow of electric current is opposite to the flow of electrons. Right. In this way. Okay. So that's why in a circuit what happens if we take a small circuit. If we take a small circuit, draw a diagram of a small circuit. It is like that. There is a battery. Its positive terminal. This is negative. This is positive, then negative, and this is ammeter, and this is resistance, right? And then we have a key like this. So current is flowing from positive to negative. Current is flowing from positive to negative in this direction, right? In this direction, and electrons are moving from negative to positive, right? This is flow of electron, red color. Green color is flow of positive charges. Done. Right? I is equal to Q upon T. I told you. I is equal to Q upon T. Well done. That is Coulomb, Coulomb upon second, and that is equal to 1 ampere. Right? Ampere. Now we have another term with us that is known as potential difference, right? Hello, where you get busy? Potential difference, potential potential difference, right? Or electric potential, right? So what we have, if there is a charge q, there is a charge q, so it will have, this is charge q, so it will have an electric field around it, right? So there is a electric field of charge q, right? And there is a test charge, unit test charge is q, right? Unit test charge, unit test charge. By default, it is positive, right? And it is charge is, this is negative charge. Q is having negative charge, right? Negative charge. This is having negative charge. It is having positive charge. Okay. So, and the distance between these two is infinite. Infinite distance, right? Infinite distance is there. So to bring these charges, to bring these charges from infinity to within the electric field, right? This is, so this is from this unit charge from infinity to within the electric field, right? Amount of work is done is known as electric potential, right? What I said? Okay. So what is amount of work done? Amount of work done to bring bring unit test charge, unit test charge from, amount of work done to bring unit test charge from infinity to within electric field, within electric field, known as electric potential. Electric potential. I hope you understand. Amount of work done to bring unit test charge from infinity to within electric field, known as electric potential. So E is equal to W upon Q, right? Now what happens to bring change in position of this charge? Up within the field, if you are bringing it here, it is positive charge, it is negative charge, so definitely you have to do less work because there is a force of attraction. But if you bring it away from this, then you have to do a lot of work because you have to work against the attraction, right? And it is also depending upon the distance between them. So that's why now amount of work done, amount of work done, amount of work, amount of work done, amount of work done to bring, amount of work done to bring change, change in position of a charge, position of a charge within electric field, electric field known as potential difference, potential difference, right? What I said, I said to bring change in position, amount of work done, amount of work done to bring change in position of a charge within the electric field known as potential difference, and amount of work done to bring a unit charge, unit test charge from infinity to within an electric field is known as electric potential, right? So V is equal to, so V is equal to electric potential difference, V is equal to W upon Q, right? That is 1 volt is equal to 1 joule, 1 joule per coulomb. Got it? So 1 volt, volt is equal to V is equal to W upon Q. So 1 volt is equal to 1 joule per coulomb, right? And if we take 1 joule, 1 volt into second, then is equal to, 1 second is equal to 1 joule, right? 1 volt into second is equal to, no. 1 volt into coulomb, not second. Man, there you are. This is 1 volt into coulomb. Cross multiply. So 1 volt into coulomb. 1 volt into coulomb is equal to 1 joule. So it is visible to you now. So 1 volt coulomb is equal to 1 joule. So if I say 1 electron volt, it means 1 electron is having a charge of 1.6 into 10 to the power minus 19 coulomb, and potential difference is 1 volt. 1 volt. Then what happens? This 1 will be multiplied and you get 1.6 into 10 to the power minus 19 coulomb volt, right? And 1 coulomb volt or volt coulomb is equal to, hello, नहीं आ रही है, but I hope you are okay. So 1 volt, 1 electron volt is equal to 1.6 into 10 to the power minus 19 coulomb volt. 1 coulomb volt is how much? Arey yaar, you are not with me, na? That's why I understood. Here it is written 1 volt into coulomb is equal to 1 joule. So this 1 coulomb voltage means how, what? It is also converted into joule. What you are doing, man? Not convert, just substitute. Because 1 volt into coulomb is equal to 1 joule. And here is written coulomb volt. Yeah, volt. So it will be no 1.6. There will be joule only. Remaining magnitude remains same. So it will be joule. So it becomes, what happens? It is 1 electron. It means 1 electron volt. 1 electron volt is equal to 1.6 into 10 की power minus 19 joule, right? So this is the value of 1 electron volt which is going to be asked, right? So this is we studied about for current and potential difference, right? Current and uh, potential difference. Should I rub this? Okay. I hope you are busy. You are busy. You are busy somewhere else also. अच्छा, अच्छा. What understand you are distracted. Anyway, अच्छा, 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 अच्छा. Anyway, I'll just take 10 minutes more. So now we discuss upon Ohm's law.
Hello.